Hi everyone, I hope you're okay and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the second question from the media examination which was written in the province of Eastern Cape in the year of 2024. Please do expect a total number of 7 videos since the question paper had 7 questions in total, and that simply means each and every question will have its own video. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your media exam, your preliminary exam, and most importantly your final examination. So please do share the video to your peers so that they may have the same edge as you. And please guys, do help us grow the channel by just subscribing. Okay, question 2 guys is just an organic chemistry question. And if ever guys are given a diagram like this, the first thing you need to do is that if ever you are given a structural formula, you must just write down the IUPAC name. And if you are given an IUPAC name, you must just draw the structural formula. Ne? But sometimes you are given molecular formulas like that. The first thing you need to do, draw the structural formula and then write down the IUPAC name. Ne? Before we can start answering the questions. Okay. Compound A, we only have 1 carbon and 3 hydrogens as well as a chlorine ion over there. So this is a haloalkane, and the IUPAC name of this haloalkane is called chloromethane. Chloromethane, okay. And then compound B, we are given the same structural formula. All you have to do guys is to just write down its IUPAC name. I can see that it's an alkene because it has double bonds between adjacent carbons. Okay, so I need to start numbering my carbons from the terminal that is closer to the double bond. Ne? Are you together? So if I start numbering guys from my left hand side, I can see that I have carbon number 1, 2, 3, 4 and 5. Are you together? But if I wanted to start numbering from the right hand side, I would have said carbon number 1, 2, 3, 4 and 5. Whenever guys I start numbering from the right hand side, my functional group is not closer to the terminal carbon. Are you together? So that's why I need to start numbering from the left hand side. And obviously guys, whenever I name this compound, I can see that I have a side chain at carbon number 4. So whenever I name this organic compound, I need to mention that side chain over there. At carbon number 4, I have my methyl. Are you together? And the parent chain has 5 carbons. Excuse me. So I'll simply have pent 2 in. This 2 in just tells me that the double bond is between carbon number 2 and 3. Okay, now let's go to compound C. Compound C, it's a ketone. Its IUPAC name, it's a butanone. Butanone has 4 carbons. That means it will be like this, 4 carbons. And then there's only one type of butanone guys. That's why they didn't have to say butane-2-one. Are you together? You can either draw your double bond O over there like this, or you can shift your double bond O and draw it over there. You'll still have butane-2-one. Are you together? Why? Because the functional group will still be in carbon number 2. So just draw your hydrogen, 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 hydrogen. Your hydrogen. Eh? Please guys, do make sure that your carbon is surrounded by 4 bonds. Are you together? Not more, not less. Exactly 4 bonds. Ne? So this is the structural formula for butane-2-one. Okay, and then compound D. Compound D is an alcohol. How do I know that it's an alcohol? Because it has a hydroxide ion. And this type of an alcohol is a secondary alcohol. Why is it secondary? Because the carbon which is bonded to the hydroxide ion is also bonded to other 2 carbons. Are you together? So it's a secondary alcohol, number 1. So let's name this type of alcohol. We must start numbering from the terminal, which is closer to the functional group. This is our functional group, right? So we'll start numbering over here. This will be carbon number 1. Please, guys, do not think this is a side chain. Eh? You can never have a side chain at the terminal carbon. So this will just be carbon number 1, carbon number 2, 3, 4, 5, and 6. Ne? I can see that at carbon number 5, I do have my 2 side chains over there. Ne? But obviously, guys, whenever I name this organic molecule, I just need to mention the substituents first. Are you together? So at carbon number 5, I'll simply say 5.5. It's dimethyl. It's dimethyl, and then the parent chain has 6 carbons, so it's hexane. The alcohol is in carbon number 3, so this will be hexane 3 all. Are you together? And then for compound E, guys, I believe that you are supposed to determine the organic molecule compound E. There's a higher chance that it will be an ester or rather a carboxylic acid. How do I know that? Because it has 2 oxygens. Ne? The only organic molecules that have 2 oxygens, guys, in our scope, it's either carboxylic acid or an ester. Nothing more. Ne? Okay, let's answer the questions now. They want us to define the term homologous series. Okay, a homologous series, guys, is just a group of compounds that have the same general formula. Are you together? A homologous series is just a group of compounds that have the same molecular general formula rather, and the same functional group. Are you together? Okay, they want us to write down the letter that represents the following. A hydrocarbon. Remember that, guys, a hydrocarbon is just an organic compound that consists of hydrogens and carbon atoms only. So the only compound which is a hydrocarbon there is compound B. Are you together? And then 2.2.2, they want us to identify an alkane, a haloalkane rather. Haloalkane is compound A, because we do have our halide over there. So compound A is a haloalkane, and remember the IUPAC name of our haloalkane was chloromethane. Ne? Okay, 2.2.3, they want us to identify an alkene. An alkene is an unsaturated hydrocarbon. We only have one hydrocarbon there, that's compound B, and the IUPAC name of the hydrocarbon is just 4-methyl pent-2-ene. So compound B is our alkene. The compound that contains the carbonyl group that is bonded to 2 saturated carbon atoms. If you can check there, guys, the only compound that has a carbonyl group is compound C. A carbonyl group, guys, is a functional group for ketones. Are you together? And yes, our carbonyl group is bonded to 2 adjacent carbons. So compound C is our ketone. So we can simply write C over there. Ne? Okay. Then 2.3 is compound D primary, secondary, or tertiary alcohol. Give a reason. Compound D is a secondary alcohol. Why? Because the carbon that has a functional group of alcohols is bonded to 2 adjacent carbons as well. Are you together? The carbon that has a functional group is just bonded to 2 adjacent carbons. If it was a primary alcohol, guys, the functional group was just going to be at the terminal carbon. But if it was a tertiary alcohol, the functional group was going to be bonded to the carbon, which is also bonded to other 3 carbons. So over here we simply have a secondary alcohol because our carbon number 3 is only bonded to 2 carbons. Okay, and then 2.4, they want us to write down the general formula for the homologous series to which compound B belongs. Compound B is an alkene. So the general formula for alkenes is just CnH2n. The IUPAC name of our alkene, we said it's 4-methyl pent-2-ene. It's 4-methyl pent-2-ene, right? And then the IUPAC name for compound D, we said it's 5.5 dimethyl hexane-3-ol. That's 5.5 dimethyl hexane-3-ol. Okay. And then for compound C has a functional isomer. Define the term functional isomer. Functional isomers, guys, are organic compounds that have the same molecular formula but have different functional groups. Are you together? For example, an ester is a functional isomer of a carboxylic acid. An ester, the functional group for ester, is called an ester link, and then the functional group for carboxylic acid is called a carboxyl ion. Are you together? Same applies with ketones and aldehydes. Both of them are functional isomers. The functional group for ketones is a carbonyl group. The functional group for aldehydes is a formyl group. Né? So I already know that since they are talking about compound C, which is a ketone, its functional isomer has to be an aldehyde. Its functional isomer has to be an aldehyde. Né? Okay, we've already defined over there the functional isomer, but let me repeat it. Functional isomer, guys, is just two compounds that has the same molecular formula but different functional group. Né? They want us to draw the structural formula of the functional isomer of compound C. I know that, guys, compound C is a ketone, so its functional isomer is an aldehyde. Are you together? So the functional isomer of butane-2-on will simply be butanal. This will be just the functional isomer. Are you together? Remember that when the double bond O was there, we had a ketone, but whenever the double bond is at the terminal carbon, we have an aldehyde. Né? This is the structural formula, but if you wanted to write the IUPAC name of this structure, you'd have simply said this is just butanal. Butanal, né? Okay, now let's take 2.6. Compound E reacts with alcohol P in the presence of a concentrated sulfuric acid to produce organic compound Q, as shown by the incomplete equation below. Okay, we are mixing an organic compound with an alcohol, né? and we are forming another organic compound. This simply means that this guy over here is a carboxylic acid. And remember that, guys, I told you that compound E can either be a carboxylic acid or an ester. So now the examiner tells us that compound E is a carboxylic acid because whenever you react it with an alcohol, you will form an ester. Are you together? This type of a reaction, guys, is called esterification. Yeah? Or you can say it's a condensation reaction. Okay, and then we are told that the percentage composition of compound Q is given below. 58.82%. There's 58.82% of carbon, 9.81% of hydrogen, and then 31.37% of oxygen. 31.37% of oxygen. Eh? Okay, now they want us to write down the name of the type of reaction that occurred. Remember, guys, I told you that it's esterification. Eh? The name is just esterification. Or you can say it's a condensation reaction. Yeah? Okay, determined by calculations the molecular formula of organic compound Q. Over here, guys, since you are given the percentage composition, all you have to do, guys, is to find the empirical formula and then find the molecular formula, right? So since you are not given the the molar mass of compound Q. It simply means that the empirical formula will be our molecular formula. Okay, let's just do so. How can we do that? Remember that, guys, we have carbon, we also have hydrogen, and then we have oxygen. Whenever, guys, you are given a mass, you must always, whenever you're given percentages, we must always change it into masses, guys. Always change it into mass. So over here, I'll simply have my mass of my compounds in grams. Are you together? I was given the mass of my the percentage of my carbon to be 58.58. That's 58.82 rather, not 58. So this is just 58.82 grams. And then the hydrogen was given to us as 9.81%. That's 9.81 grams. And then the oxygen was given to us as 31.37%, which can be also written as 31.37 grams. And then all you have to do is to find the number of moles. Mass all over the relative atomic mass number. I just divide the mass with the molar mass. Remember that, guys, the molar mass for oxygen, let me write, for carbon is 12, hydrogen is 1, and then for oxygen is 2. Please remember that, guys, don't forget that. Let me write them here. I have 12 over here, 1, and then did I say oxygen is 2? Yo, ngizotrenda mina ngamanga. Okay, the molar mass for oxygen is 12, right? Is 16 rather. So for me to find the number of moles, I just need to say 58.82 divided by 12, and this will simply give me 4.90. And then 9.81 divided by 1 is just 9.81. Then 31.37 divided by 16, this is just equal to 1.96. Are you together? Okay, and then for us, guys, to find the ratios, we must just divide all of these by the smallest number of moles. The smallest number of moles we have is the ones for oxygen. Let me highlight them with black. We are dividing all the number of moles we have by 1.96. I'll simply say 4.90 divided by 1.96. And then this will just give me 2.5. And then 9.81 divided by 1.96. This will just give me 5.00. So just 5. And then 1.96 divided by 1.96, this will just give me 1. But remember that, guys, these things are supposed to be our subscripts over there. We're supposed to have 2.5 C2.5 H5 and O1. But it doesn't look cool, guys, for us to have a subscript which is a fraction. Are you together? So what I have to do, guys, to fix this problem is to multiply my ratios by 2. Multiply my ratios by 2. All of them. And whenever I do that, I'll simply get 5 over there. 2.5 multiplied by 2 is 5. 5 multiplied by 2, that's 10. 1 multiplied by 2, that's 2. So therefore, I'll simply have C5, H10, and O2. The empirical formula is just C5, H10, O2. And so is the molecular formula, guys. So the empirical formula is just our C5, H10, O2. So this is the molecular formula of our ester, the molecular formula of compound Q. I now know that compound Q has a molecular formula of C5, H10, and O2. Okay, and then now we are supposed to determine compound E. If you are told that the molecular mass of compound E is 74 grams per mole. Are you together? Okay, please remember that, guys, whenever, guys, I have my carboxylic acid, the number of hydrogens is always 2 times the number of carbons. If ever I have 4 carbons, I will simply have 8 hydrogens. If I have 10 carbons, that means I will have 20 hydrogens. Okay, since, guys, I'm given this molecular mass, I know that my carbon, okay, the number of carbons, what am I doing now? Okay, the carbons plus hydrogen as well as oxygen should just give us 74 grams per mole. Okay, if, guys, I have X number of carbons, that means I'll have 2 times the number of carbons over there. Oxygens, guys, I already know that there are 2 oxygens. I have 2 times oxygens. Are you together? This must be equal to 74 grams per mole. Grams per mole. We are given the 74 grams per mole. But remember that, guys, the molar mass for carbons is just 12. So this will just be 12x. And then the molar mass for hydrogen is 1. So 1 multiplied by 2x plus 2 multiplied by the molar mass for oxygen is 16. This is equal to 74 grams per mole, right? So I'll simply have 14 is equal to 74 minus 2 times 16. This will simply give me 42. So 12x plus 2x is 14x. And then 74 minus 2 times 16 is 42. If I divide both sides by 14, then x is basically equal to 3. Are you together? So if x is 3, guys, that means I have 3 carbons. Remember that the number of hydrogens is always twice the number of carbons in carboxylic acids. So I have 3 carbons and 6 hydrogens, and obviously 2 oxygens, as I was told you there. Are you together, guys? And since this guy over here is a carboxylic acid, I already know this guy is a propanoic acid. It's propanoic acid. Are you together? So we simply have C3H6O2, and the IUPAC name is just propanoic acid. The IUPAC name is propanoic acid, right? Okay, and then now we are supposed to determine the organic compound. We are supposed to determine the organic compound that Q was produced. Determine the organic compound Q that was produced. Write down the IUPAC name and the structural formula. Okay, so I now know that, guys, I know that compound Q, guys, we found it to be C5, H10, and O2. This will be plus water. But please note that, guys, we had alcohol P, plus compound E. We just found compound E to be equal to C3H6O2. Are you together? For us to write down the IUPAC name of this guy, we must know the alcohol first. Okay. So since guys, my carboxylic acid had 3. Excuse me, guys. Since my carboxylic acid had 3 carbons, it simply means that my alcohol had 2 carbons, because the number of carbons which appear here should be the same as the number of carbons there. Are you together? So that means I had 2 carbons, and hydrogens should be balanced as well. I have 6 hydrogens over there on the left hand side, but on the right hand side I have 12 hydrogens. Are you together? So that means that's 6 over here. Okay, and then the number of oxygens, I only have 1 over there, because this is 2, and then whenever I add that will be 3, né? I also have 2 and 3. So my equation is balanced. This is the alcohol that was used to form compound Q, right? So if ever, guys, we add this thing properly, né? We simply have our carboxylic acid. This is not necessary, guys, but I'm just doing it for you to be able to see what's happening. Plus our alcohol, that's OH. Okay, and then please remember that, guys, your alcohol donates this proton, and then your carboxylic acid donates an OH. Are you together? In the presence of sulfuric acid, and then we'll end up having 1, 2, 3, and then an O as well. Plus H2O. Okay, this part over here, guys, is indicated there. Are you together? And then all you have to do was to just remove that part, and then join these two compounds together to form this compound over here, to form our ester. Whenever, guys, we name our ester, okay, whenever we draw the structure of our ester, it's supposed to look like this, né? It has an H over there. It's supposed to look like that, number 1. Are you together? And whenever we name it, the IUPAC name will simply be ethyl propanoate. Are you together? The alcohol part of it is regarded as a substituent, and then the acid part is regarded as a main compound. Are you together? So the IUPAC name is just ethyl propanoate, and then the structural formula is that one, né? But let's just draw it there at the bottom. It will simply be CH3, CH2, C double bond O, and then CH2 and CH3. This will be the structural formula of our ester. Are you together? And obviously the IUPAC name is ethyl propanoate. That's how, guys, we're supposed to tackle this question over here. So please do stay tuned and wait for more videos. Thank you.